Hello and welcome back. Today we are in day 10 of this Mule advanced training. It has been many days since I created a video because of my busy schedule. Anyways, let us get started. So actually I wanted to cover a very important topic, security. I directly actually wanted to talk about security in any point platform, but I understood that there is a gap in understanding for many students. So some fundamentals are not clear for many students. So I thought I will create videos on security fundamentals today so that when we go to the actual topics on any point platform, you'll have a very clear understanding. Some of you might be knowing the topics which I'm going to discuss today, but listen to them carefully. Your thought process will change about the same topic. The way you think will definitely change. So let us get started. I will share my screen. So today the agenda will be uh, to discuss about encryption, decryption, certificate, signature. And then we will discuss about OAuth actually and JWT. So let us get started. So first topic is encryption. I hope all of you will be knowing encryption. Why do we do encryption? So that whenever we are transferring data from one application to other application, nobody can understand the data even if somebody sees it. So there are two types of encryption actually: symmetric encryption and asymmetric encryption. What is the difference between symmetric and asymmetric? Actually, whenever we want to encrypt any data, we need to use some algorithm like RSA, etc. And we need to have some key. Suppose for encrypting some data, let us assume that I want to encrypt a string hello. For encrypting this data, if I'm using a key, and if same key can be used for decryption, that means the sender will be using same key, receiver also will be using same key. So if same key is used for encryption and decryption, that means we are using symmetric encryption. Okay. But then what is asymmetric encryption? In an asymmetric encryption, there will be two keys: private key and public key. The idea is if data is encrypted using private key, it can be decrypted using public key and vice versa. That means if the data is encrypted using public key, it can be decrypted using private key only. Okay. Now let us try to understand a scenario. Application A, application B. Each of these applications are having their own private keys. For A, let's assume that its private key is private A, public key is public A. Similarly, B has its own private B, public B. Now, there can be application C also. Actually, applications can exchange their public keys in multiple ways. Public key can be actually distributed anywhere. Okay, but private key is private as the name says. Now, if application A is sending data to B, for example, it is sending a string, for example, a credit card number. Some credit card number is there. It wants to send this sensitive data to B. It has to encrypt it. Now, can you guess by using which key should the encryption be done? Just pause the video and think by using what key? Private A, public A, private B, public B. So which using what key should A encrypt if it is sending to B? Okay, let me tell you my answer. Pause the video now also and think. Okay, let me tell you my answer. Suppose if this is encrypted using private A, for example. If data is encrypted using private A, it can be decrypted using public key, right? But application B also knows public key. Application C also knows public key. That means application C also can decrypt this data. Hmm, not good, right? So actually what happens, the encryption will be done using the other party's public key. That means in this case, it is public B. If data is encrypted using public B, it can be decrypted using only private key of B, right? Nobody else knows the private key of B except B. That means data encrypted using public key of B can be decrypted by only B. Even if when the data is in transit, if application C gets the data, it cannot decrypt it. So the sensitive data is secure. Hope now you understood, right? So whenever we are doing encryption will always be done using the other party's public key. Okay, pause the video. Please try to visualize, and once you get the idea, then move on. Now we understood about symmetric and very good. Now the next thing I want you to understand is signature. What is the purpose of signature? Okay, I'll tell you beautifully with an example. Again, application A is there, application B is there, application C also might be there. Now, A want to send uh, some normal data. It is not sensitive data like credit card. Let's assume that A want to send hello. It is not sensitive data, right? Now, it is okay if when the data is in transport, when the data is in transit, it is okay if some other application like C gets to know the original data. That's okay. But the intention is actually, it is possible that when the data is in transit, some hackers might intercept this data. Some hackers application like application D can intercept this data, tamper the data, modify the data from hello to say bolo. Okay. And send the tampered data to B. When the B receives the data, it does not understand whether data is tampered or not, right? So that means whatever data A is sending, that is not the same what B is receiving. Oh, this is too bad. So what we want is when application A is sending data, it should make sure that somehow we should do something so that when data reaches B, B should be able to validate whether data is tampered or not. Okay. Now let us try to understand the ideas. Okay. Now, whenever application A is sending data, say hello, what it can do is it can compute digest of this data. Again, what is a digest? There are a lot of digest algorithms by using which we can compute digest, right? So secure hash algorithm, SHA, or message digest algorithms, etc. There are a lot of algorithms. By using any of the algorithm, let's assume that we can compute a digest. Just for understanding, I'm just representing hello digest. It is not plain like this. Assume that this is the digest. Okay. So application A want to send hello, but what it did is it created a digest, hello digest. Okay. Now this data will be encrypted using private key of A, because A is the sender, right? It will be encrypted. Digest will be encrypted with private key of A. Now, when A is sending, instead of just sending hello, it will send hello along with encrypted digest. Okay. Now the data is in transit. Let us assume two scenarios. Scenario one, data is tampered. Okay. Now application D is intercepting. What it can do, it can change hello to, for example, let us say bolo. Okay, it is intercepting and it is trying to tamper the data. It modified the original data to bolo. It can compute digest of bolo also, for example, bolo digest. But now, does application D know the private key of A? No, right? Application D does not know. So what it can do is it can encrypt the data using private D. Then this tampered data can be sent to B. Okay, now B is a receiver. It has to verify. So from whom is this B expecting data? From application A, right? So what this B is, it can decrypt this path using public key of A, because B is expecting from A, it will try to decrypt using public key of A. But can this be decrypted properly? See, this data is encrypted using private D. If you try to, sorry, this data is encrypted using private D. If you try to decrypt it using public key of A, we'll get some junk. Okay, some junk string. Then what we will try to compute digest of bolo. It will get bolo digest. Oh, both are not matching. So data is tampered. We can actually reject this data. Now let us see a normal scenario, a happy scenario where the data is not tampered. Let us remove all this. Okay, data is not tampered now. Fine. Now when actually B receives the data, what it will do, it is expecting from A, right? So it will take this part and it will try to decrypt it using public key of A. So it will get hello digest. Okay, then it will compute the digest for the original data. It will also still get hello digest. So both are matching. That means the data is not tampered or modified, right? So now in this case, this encrypted digest, we can call that this is a signature. Signature of whom? As we are using private key of A, this is signature of A. This encrypted digest is nothing but signature of A. For which data? For data hello. So does it mean that signature will change based on data? Yes, of course. Based on the data, signature also will change. So in this case, what is signature? Encrypted digest is a signature. Now here, what we are trying to do, whenever A is sending data to B, along with original data, we are sending the signature of A also, right? Now what is B doing? It is actually verifying the signature. Verifying the signature. That means how to verify the signature actually, whenever B gets the data, it will decrypt this signature with public key of the sender, right? And then it will try to compute digest of original data. If both are matching, that means signature is correct, right? B is expecting from A. That is the reason why it decrypted using public key of A. So both of these matched. That means signature is verified. That means data is not tampered. Right. So what is the purpose of signature? To make sure that data is not tampered. Or we say that data integrity is the terminology used. I normally don't prefer to use this terminology because it will be confusing you. So data integrity, that means whatever data A is sending, the sender is sending, the same data will be received by B. Data is not modified or tampered. So if somebody asks you what is the purpose of signature, to ensure data integrity, data is same from the receiving end and the sending end, right? So that is the purpose of signature, or we call this also as a digital signature. Very good. Now let us try to understand what is a certificate. It is very important. Most of you might be knowing, but let us try to understand clearly. Suppose I want to create my own certificate. There are a lot of tools to create certificate. So if you are using Java, there is a tool called as key tool to generate certificate. Actually, there are a lot of tools. Now, actually, what is a certificate? Certificate is nothing but a document which contains my details. Okay, what is my name, what is my organization, etc., etc., etc. Certificate is a document which contains my details along with my public key. Okay, it's nothing but a document which contains my details along with public key. Let me just tell you, for example, see, this is, I visited the website. Uh, I visited the Anypoint website. Here, if I click on it, it is saying connection is secure. See here, it is showing, if I click on it, it is showing certificate is valid. If I click on it, it will show the certificate of anypoint.mulesoft.com. Okay, if you see the details, certificate fields, it's having the details, like it is saying the subject key, authority key, subject alternate name. Actual subject means to whomever this certificate is given, that is a subject. It is saying the certificate is given to star.anypoint.mulesoft.com. Okay. It contains all this information and also the public key. See, this is the public key of Anypoint. Sorry. Yeah, public key of a wait, actually, where is the public key? Actually, here you can see the public key. This is the public key, right? So it is issued to this one organization unit, all this issued by whom, etc. Validity, it is valid until uh, April 23, 2024. So certificate is a document which contains the details and also it's public key. Right now, it depends on the browser. It is not showing properly. I'm not able to show, but understand that it contains the details. So what all are the details? This is the details, like certificate contains version, serial number, something, certificate algorithm, who is the issuer, etc. Subject. These are the subject's public key. Here it is the public key of the subject. Subject means to whomever the certificate is given as a subject. This is the public key. And there are a lot of other details, right? So basically, certificate is a document which contains some details. Suppose if this is my certificate, it contains my details and my public key. But the thing is, if I give this certificate to some third party, how can they trust this certificate? Suppose if, for example, I'm saying the name in my certificate says that I am Bill Gates. Okay, right? It can contain my personal details. Suppose if I created a certificate saying that my name is Bill Gates and I'll give my public key, and if I share my certificate with somebody, how can they trust? How can they know whether my name is really Bill Gates? It is a fake certificate, right? My name is not really Bill Gates. So somebody should be able to identify whether this data present here is correct or not. So normally what we do is, whenever I want a trusted certificate, I will give all my data to a certifying authority or CA. certifying authority, and ask them to sign my certificate. I hope now you know what is the meaning of signing. What they will do whenever they have to sign. Suppose there is a CA, and if the CA has to sign, what they can do? They can create a digest of my entire data. This certificate is containing some data, right? They will create a digest. And then they will encrypt it with their own private key of that CA. Then this data will be added to the certificate, and this is nothing but a signed certificate. If a certificate contains this part, encrypted digest, right, this is signed certificate. Who signed it? As this digest is encrypted using private key of CA, this CA has signed it. Okay. Actually, there are a lot of certifying authorities. For example, if you see this certificate, whatever I have shown you, uh, here you can see for any point platform who has issued this certificate, issued by something organization called as Amazon. They got this certificate from Amazon. In this case, Amazon is the certifying authority. So when Amazon is issuing this certificate, is actually signing this certificate, the Amazon might have asked some details. Hey, if you want me to sign your certificate, give me your details. I will validate. For example, if I go to Amazon and ask it to certify that these are my details, it will ask, hey, you are claiming that your name is Bill Gates. Give me a proof that your name is Bill Gates. If they verify all the details and if they are correct, then only the certifying authority will sign it. Otherwise, they will not sign it, right? So if a certificate is signed by CA, we can trust it because we trust that this CA, the certifying authority, might have validated. So to make sure that your certificate is a trusted certificate, you need to get it signed. So most of the websites will have their own signed certificate. Otherwise, if I go to a website and if the certificate is saying that it is not valid, if the browser is saying that certificate is not valid, that means we understand that this certificate is not a signed certificate and we cannot trust that website. Is it? So fine. That is the purpose of a certificate. Now, clearly you understood what are these topics. Now, in the next lecture, very importantly, we are going to discuss about what is this OAuth and JWT tokens. Okay, so I'll meet you in next lecture.